Alright, let's do a. Let's. I'm like so done with. I don't know what to pick. I don't really like any of the. Some of the daily problems. The daily problems, they just sound so like look at this, man. Set intersections, like, bro, I'm too ass sadly cooked for that. Let's just try advanced graphs. I probably maybe might not be able to solve it, but we'll see. We'll try our best. Soon I'll be building. I want to improve my. I want to build a backend project with Go, with like zero front end possible. Um, so yeah, I want to build something cool. I'm trying to think of some stuff. Maybe I'll start it when I finish school. I'll be almost done in about few more weeks. So, but for the time being, do some lead codes since I'm still still interviewing. So let's get this working. You are given a network of n nodes labeled 1 to n. You're also given times, a list of travel times as directed edges, time I, u, v, I, w, where u, I is the source node, v, I is the target node, and okay. U is the source node, V is the target node, and V is W is the time it takes. Okay. Okay, some directed graph. You're given a signal from a given node K. Return the minimum time it takes for all the nodes. Ooh. Okay. Minimum amount of time? So maybe some traversal. So first I'll build out the graph. So it looks like this. Takes 2 because why? I don't know. We send a signal from a given node K. So we're saying node 2. Okay. Okay. We send a signal from a given node K. Return the minimum time it takes for all the n nodes to receive. So basically traverse all the nodes from source. Okay, so send, we reach that. Send, how is it 2? It takes, is this like some Dijkstra stuff? Maybe like prior queue? Let me see, prior queue? Yeah, makes sense. Okay, shortest. Okay. I still don't know what I'm trying to do though. If it's possible for all the n nodes to receive the signal. I don't get it. All right, let's see. What about this one? 1 goes to 2, starts 2, and there's no way to reach the nodes. What does a 2 represent? The minimum time it takes for all the n nodes to receive the signal. What? Okay. There are 4 nodes. We return 2 because of this. I don't get this. Like, what are we trying to do here? What is one? This is kind of a poor test case. See this. Visits each node at some time, and if that time is better than the fastest time we've reached this node, we travel along the outing edges in sorted order. Alternatively, we could use extra. What are we trying to? Minimum time it takes for the n nodes to receive it. We send a signal from a given node k. Return the minimum time it takes for all n nodes to receive the signal. 1, 2. I don't get the 2 part. Like, what are we calculating? Minimum time it takes for all the n nodes to receive the signal. Vi is the target node. Wi is the time it takes for a signal to travel from the source to target. It will send a signal from a given node. I still don't get the question. I don't know what we're returning. I can see how it's Dijkstra because we have like edges and stuff and weights. But, what? Okay, this is 1, 2. Minimum time it takes for all nanos. Like, it's okay, let me really understand it. So, like, we're trying to get through. We return 2 because 2, 3, 4. By the time it's time 2, this one has reached it, and this is the last node. So given between the minimum time it takes for all the n node to receive the signal. So that's why we return 2. At time 2, all the nodes have received the signal. Okay. So we take like the maximum. Okay. Let's do this. Default dict. I'm gonna build a default dictionary and then use kind of like a Dijkstra, or not Dijkstra, but actually, yeah, Dijkstra. Okay, we use a priority queue. We'll see. Oops. UVW in times graph of U dot append. It arrived at V at W time. Let's be more descriptive here. Source, target, time. Time, target, source. Wow. Okay, so then Q. We'll do this like a BFS type of thing. We'll use the DQ, and we'll start at let's say node K times 0. That's kind of the idea. That's the source. So yeah, and then we'll do like a BFS while Q cur. Let's do in range length Q. Then okay, so from here I calculate, okay, let's do cur dot pop Q dot pop left. So we pop left to do that, right? So we get this source. I guess we can do source time, right? That's kind of the structure we're going for. And then from here we want to pick like the smallest thing. I think that's why we should use let's use a heap. Let's use a heap. Yeah, let's use a heap. Okay. Q. So heapify Q. Or actually, should I just add heap push Q with, I'm gonna put the time first, then the node. So I want to order it by time. And it's Q heap pop Q. Yes. So we get the time, so not flipped. Time source. Okay. Now, so now for the neighbors, for every, I guess, children, neighbor in graph of source. It's not really source. It's more like node, right? So basically, wait, I don't think I need to do this. Okay. I need to keep track of like all the nodes basically, like from the source, how fast can I get to it? So I need like a let's do this. I need to do net, let's call it network default dict. Actually, yes, I will do this. So we'll do network here. Network. Do I need a value like that? I can maybe just do It's nodes. We'll do float infinity times n plus 1. Yeah. Print and let's return here. Let me see something. Four. Oh, not n. What am I doing? Nodes. Yeah. Perfect. So this represents node 1. This represents node 2, node 3, node 4. And all I want is all the values. Like I want the values here. Yeah, I just want the values here, and from a given source, right? How long it would take it to go there. So okay, for every neighbor in source, yep. Check the thing. So if there's an easier way to get there, go for it. So if neighbor is a tuple, so let me break that down. So actually, let's break that down even more. So this is a target and time. So neighbor time. So new time, which is I can't use this w let's say time plus this. If new time is less than neighbor of nodes, like that, then we will push it into, we'll do this. Then we'll do this. First nodes neighbor, that's gonna be the new time. Then then we add that to our heap. So heap push to the queue the new tuple, which will be new time plus neighbor. Simple. Then I would just return all the base of the maximum. That means that's how we know. If there's any infinities, that's a bad, so that will return. So for every node in nodes, if node equals float infinity, return -1. Otherwise, return max of nodes. Simple. Okay, wrong. Okay, I'm just returning. That sucks. Okay. Okay, I'm probably not. Let me double check something. Print. Bruh. Okay, I am traversing. Thank God. Okay. For every oh wait, hold on. Wait, graph? Yeah, graph is target and time. Yeah. So time plus this, that's the new time. Nodes neighbor equals new time. Push the new time into with the neighbor. That's the structure we're going for. Yep. Maybe we don't. Hold on. How many of them do this? Uh-oh. I don't know. Wait, hold on. I messed up. Oh, I know why. Okay, I know. I know exactly why. Because the first one. Close. Hold on. Because the first. Okay, let me adjust this. Actually, it's fine to have it n, but I need to adjust the node values. So I don't do this weird syntax. Yeah. Let's just do if no neighbor -1. Yeah, so it's adjusted. So the indexes are like adjusted for, so I don't have to do that weird like looping. Still? Okay, that's weird. Let me just print nodes real quick. Print nodes. Okay. I think I should have okay, we're not. Yeah, this is freaking weird. Okay. We're actually not traversing oh my god, you idiot. What? Okay, better, but I'm still getting it in infinity. Why? Wait, so what is this one? This is 0, 1. So basically node 2. Oh, why would you go to yourself? Wait, this is not directed, so how would it even be going to it? So you can't. Okay. So that's done. Oh shit. Okay. I need to fill this out. I know it's that my node is time 2, so hold on. Times. Okay, maybe having a map is better, to be honest. Nah. Should I have a map instead? For every I in range of 1 through n plus 1. So we want, yeah, plus including the 4. So nodes of I equals float of infinity. Yeah. I think I can do this in a single thing, but I don't care. And I don't need to do this shenanigan. Dot values. Wait, why am I? This is just easy. Just if the maximum equals float infinity, I need to do if then return. Ooh. Hold on. Return -1. Else. Max nodes. Wait, is this how you do? Wait, if else return statement. Bro, I'm freaking brain rotting. You motherfucker, you don't even know how to do this shit. Okay, if return, okay, it's -1. Okay, return -1. I got it now. I get confused with Java. If max of nodes equals float infinity, else max nodes. Yeah, I don't even need to check. Like, that's a stupid check, bro. Okay, how about this? GG, boys. I don't know how to solve this. Oh, no. Dot oh my god. Dot values. Because I want the keys, not the not keys. I want the values, boys. Oh my god, bro. Really? Something broken now? If new time is less than nodes of neighbor, yeah. Okay, I'm still getting -1. Why? Hold on, let me print nodes. One. Okay, yeah, I remember. Oh yeah, I forgot that back. So, okay, here, let's do it here. Push here, and the nodes of k equals 0. Actually, okay, we'll do here. If I equals k, else nodes of I equals 0. Right? We start at the time 0 because, yeah. Yes, bro. Finally, bro. This is so annoying. Alright, see you guys tomorrow.